This is the second version of the site. It's here. It has a lot more features and it's considerably more robust. However, it doesn't have a lot of content posted yet at the moment. I've signed up as a student for the moment, so you'll see what the student would see. Down the left-hand column, there's a series of units. Let's go to Unit 7. This site has some metrics implemented. So I haven't used this much, so it's set at 0%. I haven't done any problems. As with the other site, there's reference materials, videos, practice problems, examples, and quizzes. I'll emphasize the practice problems because that's the most important part of any of this stuff. If I click on practice, this particular problem is a multiple choice problem. It's based on typing in 2 lines of MATLAB code. The help features are compressed over here under this tab. There's a help section that will walk you through various steps to solve the problem. There's also additional related practice problems. If I click on this one, that gives me another problem that's similar to the first one. It has its own set of help. So there aren't any help steps in this one, but there are related materials. So I can see an example if I want to. The examples can be either videos or in PDF forms, as this one is. The main feature of this site over the other site is that there is an interface for an administrator to create problems. Let me sign out from being a student and log in as an administrator. Now I've signed on as administrator to a different site. This is an introduction to math site. The other site was more or less of a sandbox to play around with and test things. Again, we have a set of units here as administrator, but we have the ability to add new units. Also, we have the ability to edit lessons within a unit. For the purposes of creating practice problems and quizzes, each lesson is divided up into sub-lessons. The sub-lessons are typically hidden from the students, but they're useful for organization from an instructor's point of view. Any instructor will generally want to make sure that the problems seen by the students cover all the topics and problem types contained in any lesson. Let's take a look at the practice problems in 1.2.d. Okay, I'll go through a tour based on an existing problem, and then after that I'll show you how to create a new problem. Problems are in 2 categories. There's regular questions, there's 2 of those, and then there's a separate category for help steps. So the help steps are based on other problem types. Let me go to one of these questions, select this one, get a preview window for this problem. Notice that I can create equations, I can have text, there's the ability to put pictures here. Maybe most importantly, there's an input box that supports mathematical expressions and some labeling to the left and to the right of the input box. If I want to edit this question, just click here. Now this takes you through a series of steps up top. The first part is the question page. On this page, you give the question an identifier and set up the problem statement. At this point, you can also tag it as either a normal or a help type problem. If it's normal, it's a regular question. If it's help, then it'll show up on the list of help steps that you can add to any given problem. It's also possible to set a time limit on a problem if you want to. The next page is to set up the answer. You put in the correct answer. You get to choose whether you want to allow mathematical equivalence or not. You also get to modify the symbols that show up in this pop-up menu of math expressions. For example, suppose I want a multiplication sign. The code for that is \times. That gives me a little multiplication symbol. I can add that to my list. Now I have a little multiplication sign I can put in my response. We also have labels we can put on the left hand and the right hand side of the input box. We can allow mathematical equivalence or just do a straight check to make sure 2 strings match. Finally, you set a total number of points for the problem. The next page is assistance. On this page you can identify hints. You can also add help steps. This particular problem has 5 help steps that have been added. Those are taken from that list of help problems on the main page. There is also an option to put in the solution if the student gives up. After that, go to the next page, which is reference materials. You give each set of materials a title. You can either put a URL in here, or you can upload materials like a PDF file. You can also choose related practice questions from this list. So Unit 1, go there. I can pick a problem from, say, sublesson 1.2.C and add that to the possible practice problems that might help with this problem. The final page is a preview of the problem. It has the problem statement, gives you the answer box and the associated left and right labels. It also gives you a breakdown. I didn't put a hint in. There are 5 help steps. There is a give up option, and there are 3 sets of related materials. One important thing is that you can tag each problem with a descriptor. These provide a category for problem types. I've set them up based more or less on what's called Bloom's taxonomy. Mnemonic just means that you have remembered some kind of factoids from the course materials. Analysis and synthesis type problems mean that you can solve problems based on the course materials with significant variations from the given examples. Finally, design and evaluation type problems indicate that you can apply the concepts to real-world problems. All of these tags are color-coded. These colors will be shown to the students so that they can assess how well they're progressing through the levels of competence that are expected. This is kind of a big deal, since students tend to be poor at assessing their own performance. This means that they tend to gravitate toward passive tasks, like watching videos. They then assume that if they, quote, understood, unquote, the video, then they've mastered the concept. However, this approach typically means that they can't solve unfamiliar problems. Once again, the goal here is to help students assess their performance and steer them towards more effective active learning methods. Finally, you can either save your changes or just bail out and get done with that problem. What I've shown so far has been in the context of an existing problem, which let us go pretty quickly. But now let's take a look at the types of problems and how a problem can be created. If I want to add a new question, just click here. There are currently 8 types of questions that are supported. Best choice and multiple select both simply require students to recognize a correct answer. Answer input requires a single valued response. The response can be checked for mathematical equivalence or for an exact match with a given value or string. Coding problems allow students to enter programmed results using one of 2 common engineering software packages, either MATLAB or Octave. The table input allows users to enter an array of values. Matching is a typical pair of lists that you match individual items in. Multiple sub-questions and nested questions allow for organizing multiple single answer problems as an overall whole. The coding type problem leads to a new set of problem types. So let's take a quick tour of that option. So click on coding, confirm that I want that kind of problem. It's given a default name for the question. I don't really care, so I'm going to enter some garbage for the question text. Now this tool allows automatic grading of computer programs in either MATLAB or Octave programming packages. A vaguely similar tool that competes with this is MATLAB's Codey coursework tool. However, that tool seems to be primarily an instructor tool to have code automatically graded. This site could be used in that way, but the primary objective, again, is to provide feedback to students. In this system, we use an open source software package called Octave to grade MATLAB code. We can use this tool to base the class around Octave as well and reduce student costs. To be honest, I haven't kept up with developments in MATLAB's Codey coursework, but I wasn't impressed the last time I looked at it. That was several years ago, though. I've made a concerted effort not to check into that because I didn't want to be contaminated by what they were doing. There are several different ways you can input a set of computer code in this particular program. You can write script files. or functions and submit a single file. You can create multiple files that work together, zip them into a folder, and submit the entire folder. You can also type your program directly in a text interface and have the commands evaluated that way. I'll use that option. Then you set up your grading criteria. You can check to see whether the student's file name is correct. That particular option doesn't pertain to a text field. You can then set up additional test cases on which you can grade the code. You can see whether they've got initial variables set properly. You can check for variable names. You can check for data types of the individual variables. You can check to see whether individual variables have the correct values. I'm fairly proud of the graph option. It checks a selected number of properties of a graph to see if the student's graph looks like it's about right. So I can check to see if the legends are right. I can check the data values. We can see whether the axis labels are right. All of those things I can enter things that you compare the actual output to. That's most of the features. We can at least use this video as a jumping off point for you to ask me questions about other features.